Learn circle geometry tricks with Tutor Jenny. Welcome. Meet me. My name is Mary and further maths tutor, and I've been teaching for over 5 years. I'm also a digital tutor and an AI literate. I am the founder of a physical and online tutoring educational center, the Maths Court. So welcome on board as I take you through maths tricks and tips. Again, I am Mary Jennifer, a mathematics and further mathematics tutor who is a digital tutor who teaches both online, physically, and even in the classroom. So welcome on board. This is the Maths Court. This is where we jail all mathematical problems. We send them to exile. And about TMC, the Maths Court, this is an educational center that, like I said earlier, that offers both physical and online mathematical training. And we tutor students from kindergarten level to confidence in mathematics. Then we help with examination preparation. We help with your WAEC preparation, your JAM preparation, everything about as we make you judges to sentence math problems to life imprisonment. So what will you be learning? In this course, you will be learning tricks to understanding circle geometry, and you'll be learning the first theorem, midpoint of a chord, and how to solve questions on this theorem. I hope you're following. Get a pen, get a book, and listen attentively. So, I'll be taking you through the first theorem. The first theorem is at the midpoint of a chord, And this theorem states that a straight line drawn from the center to bisect a chord, which is not a diameter, is at right angle to the chord. And I call this theorem the half-shoe theorem. Why? Because it looks like an half-shoe. Yes, it looks like an half-shoe. You have the tip, you have the base, then you have a bisector from the center of the circle to the chord. So I call it a theorem. Wherever I see an half-shoe, I know this is the first theorem. It helps you not to mix up these theorems. So let's solve examples. The first example says reach a distance of the midpoint of the chord from the center of the circle and calculate the length of a chord of the circle of radius 26 centimeters if the chord is 10 centimeters from the center of the circle. So we're going to be taking these questions bit first and then example 2. Get straight into it. Listen to the question again. The question says a chord from the center of the circle. Dealing with circle geometry, it is very wise that I draw my circle. So, draw your circle, show the chord. I hope you all know at this point what a chord is. It is not a diameter. I have a chord, I have the center of my circle, and I indicate the radius of my circle. Do not forget that the radius is equal. It is a distance from the center of the circle to every other point, and it is equal. Okay, this is a chord which is 12 centimeters from what the question has told us. Then we have the radius of the circle. The radius of the circle, which is 10 centimeters from the question. These two parameters were given from the question. And we have a distance from the center of the circle to the midpoint of the chord, which is unknown. This circle, it looks like an half-shoe. So, I'm not wrong if I call it half-shoe theorem. So let's move ahead. This looks all nice, but naming your angles helps us to know what to do. Okay, I'm naming this MA, then B. Okay, So I'd go ahead to tell you that my line MB, which is the chord, is 12 centimeters. This is given from the question. I also have my line MA to be 10 centimeters. This is also given from the question. These are parameters that were supplied to us from the question. And the question is P, the midpoint of the chord. I would name it P. Okay, so we have another line MP, PB. Recall, the chord is MB, but the line AP has divided the chord MB to MP and PB, which is actually equal to each other, because the theorem says that this is a midpoint of a chord, and this straight line drawn from center of the circle, it bisects the chord into two equal halves. So line MP is equal to line PB. Good. So we don't lose focus of what we are doing. I am redrawing the circle. That is the bisector. That is the radius. M, P, B, and the center of the circle is named A. I have 10 centimeters as my radius. I have line MP to be 6 centimeters and line PB to be 6 centimeters, making line MB 12 centimeters, which is given to us in the question. So I'm drawing this out to show you my half shell. Can you still agree with me? Are you still doubting? Have you agreed with me that this theorem is an half shell theorem? Good. Now we have the line MP to be 6 centimeters, line MA to be 10 centimeters. And this has formed a right angle with the bisector. It is at right angle to the chord. And from here we have a right angle triangle, which is the triangle MAP. A right angle MAP. Okay. This right angle has line MA to be 10 centimeters, then it has line MP to be 6 centimeters, and line PA, which is the bisector of the chord, and the distance from the center of the circle to the chord is what we don't know. Remember, line MA square is equal to line MP square plus line PA square. This is from Pythagoras theorem. Hypotenuse square equal to opposite square plus adjacent square. I hope you can remember that. Now we know line MA is 10 centimeters, line MP is 6 centimeters, line PA is what we are looking for. So we have 10 centimeter square is equal to 6 square, that is line MP plus PA square. This is what we are looking for, line PA square. I hope you are following. If you're not following, please pause the video, go back and continue. As we all know, 10 square is 100, then 6 square, that is 6 times 6 is 36, plus PA square. Now, it's wise that we collect like terms. 100, once positive 36 crosses equality, it becomes negative 36. So we have 100 minus 36 equal to PA square. And from here, we have 100 minus 36 to give us 64, which is equal to PA square. And because we have 64 equal to PA square, we have to take square root of both sides. Square root of 64 equal to square root of PA square. And from here, square root, and we have line PA to be equal to square root of 64, which is equal square root of 64 to 8 centimeters. Do not forget the unit we're working with is centimeters. That means the distance of the midpoint of the chord from the center of the circle is 8 centimeters. Good. I hope you're getting it. Now let's move to the second example. The second example asks us to calculate the length of a chord of a circle of radius 26 centimeters. So this is noted length of a chord of a circle. In this case, the radius was given to us as 26 centimeters, and the distance of the chord from the center of the circle was given as 10 centimeters. We have two parameters given, radius, then distance of the chord from the center of the circle. So we have a circle, we have the chord, which the length is unknown to us, we have the center of the circle, and the radius of the circle. The radius of the circle is 26 centimeter, and the distance of the midpoint of the chord from the center of the circle is 10 centimeters. Fine. So I have the radius of the circle to be 26 centimeters. I have the distance from the center of the circle to the midpoint of the chord to be 10 centimeters. It will be wise for me to name this. So I'm redrawing it. I have my chord, I have the center of the circle, I have the distance, I have the radius 26, the radius is 26 centimeters, the distance is 10 centimeters. I don't know what the length of this chord is because this is what we are asked to look for. So I'm naming this angle as A, this is angle A, B, the center of the circle is named B, and the midpoint of the chord is D, and we have C. Okay, I have my line AB with line AD to be equal to line DC because the bisector BD has bisected the chord AC into two equal halves. AD is equal to DC. Okay, having known that, then we also note that line AB is equal to 26 centimeters. This was given to us. In the question. Line AB is equal to 26 centimeters. Okay, then we also know from the question that line BD, which is the distance from the center of the circle to this chord, is 10 centimeters. These are the two parameters that were given, and we already know AD is equal to DC. So this will make our work easier while finding the length of our chord AC. Recall, AD is equal to DC. That is, the line AD is equal to line DC, and the two parameters given is the radius 26 centimeters and distance from the center of the circle to the chord 10 centimeters. Okay, from Pythagoras theorem we can see that triangle ABD is a right angle triangle, so we'll say that line AB square, which is the hypotenuse of the right angle triangle, is equal to line BD square, which is by line BD square plus AD square. Hypotenuse, Pythagoras theorem, which says that hypotenuse square equals to opposite square plus adjacent square. So we have 26 square equals to 10 square plus AD square. Are you following? If you are not following, pause and go back to the beginning of this video. Rule on this. Note one thing, Pythagoras rule is often used in the half-shoe theorem. Half-shoe theorem. So as far as this theorem is concerned, if you're not very conversant or very familiar with the Pythagoras rule, please go back and check. You can check videos that will be dropped later. So 26 square is 676, and 10 square, that is 10 times 10, is 100 plus AD square. And we already know, collect like terms, a positive 100, once it crosses equality, it becomes minus negative 100. Once a positive number crosses equality, it becomes a negative number. And once a negative number crosses equality, it becomes positive, a positive number. So take note of this. Take note of this. We already have 676, that is 26 square, which is 676. 26 square means 26 times 26. 26 square means 26 times 26, and if you multiply 26 times 26, you get 676 equal to 10 square. 10 square is same thing as 10 times 10. 10 times 10, and it is equal to 100. 10 times itself is equal to 100 plus AD square. So, having known that once 100, positive 100 crosses equality, it becomes minus 100. We have 676 minus 100 equal to line AD square. And if I take away 100 from 676, I have 576, which is also equal to AD square. AD square. And on this note, we'll go ahead to find square roots of both sides. We'll find the square root of 576, then we'll find the square root of line AD square. Definitely, square is going to cross out square root. Okay, let's go ahead and do that. 500 square root of 576 is equal to square root of line AD squared. Great. So we have square cancelling out square roots, and 576, the square root of 576 is equal to line AD on that note becomes 24, because square root of 576 is 24. Noted, because 24 times 24 will give you 576. Now we've known what line AD is. Do not forget, we already know what line AD is, but do not forget that we have the chord to be a line AC. Our chord is a line AC with a bisector BD. Go back to the B video from where we started from. You find out that the chord is line AC, and we have our diameter to be our radius, to be line AB. We have the bisector, distance from the center of the circle to the chord, to be line BD. So we already know half part of the chord. Do not forget that your line AD is also equal to DC, because your chord is line AC. So since AD, we already know AD to be 24 centimeters, therefore DC2 is 24 centimeters, and our chord line AC would be equal to 24 centimeters plus 24 centimeters, or we'll say 2 times 24 centimeters. Since line AD is equal to line DC, so we'll say 2 times of DC is 48 centimeters. So the length, the question asked us to calculate the length of the chord. The length of the chord is 48 centimeters. I hope you understand it. We multiplied 24 which is line AD by 2, or you can add it up because line AD is equal to line DC. That the first theorem here, midpoint of a chord, this theorem that states that a straight line drawn from the center of a circle to bisect a chord which is at right angles to the chord. Have you agreed that this theorem can also be half-shell theorem? This helps you cram. You don't have to cram it. The theorem can come in any form. I would draw so many in which you can see them, in which they can come out, pick them out from the circle and see what it looks like. In subsequent videos, I'll cover other theorems and what they look like. The arrowhead theorem, we have the rooftop, we have the native cap theorem, we have the ceiling theorem, and many so much. We have the X theorem, letter X theorem. So as in subsequent videos, you'll be seeing these theorems. This is showing you the different forms in which this theorem can be seen in questions. Yes, this is different forms. It could come as a right leg half shoe, as a left leg half shoe. It could come as a half shoe that is placed upright. It could be turned in any way, in any form it comes. Just go straight, solve, look for the parameters given that you are asked to solve. Then do not forget rule. Your states that the square of the hypotenuse is equal to the square of the plus the square of the adjacent side. So take note of all of this. Take note of all of this. Do not let it leave your heart. Keep it at your left so you don't eat with it with your left hand. Keep it in your right, eat with it. And like I always tell every student I meet, ensure you do not cram. Like I said, this is half-shell theorem. And hey you, start doing something. Math it's not hard. Just like this, one mathematics question a day keeps from math failure. Solve one question, solve 2 questions, solve 3 questions with 1. Okay, have it. Your class exercise, just try it. A chord of length 24 centimeters is 30 centimeters for the circle radius. The radius of the circle, the length of the chord is 16. Calculate this. For more math tips, and you follow me, like, share this video.